Okay, so on the beginning of this book, there's a bunch of review stuff that we need to go over first. So I'm going to give you a bunch of different looking definitions and maybe describe some sets. So when I talk about a set of numbers, so if I was going to talk about the natural numbers, and you'll see this a little bit. So this is review. The natural numbers is written out in your book, and you might even see it in your problems. It's an N, but the bulb is in the middle. So it looks just like that. Let me see if I can zoom in on it real quick. See that N right there? That's how it's written, okay? So did my best to redraw it up. But that stands for the natural numbers, okay? So this is the natural numbers. And if I'm going to describe the set of natural numbers, I'm going to start it with a set symbol, right? And then I'll describe that as 1, 2, 3, and then continue. Now we can do this with all sets of numbers: natural, integer, whole, rational, and real. We can do this with all the numbers. But this is a symbol that I showed y'all, but I don't think you'll remember it. Put that down. Again, real is this. That's the real numbers. You'll probably see that a little bit, and you'll probably use that a little bit, to be honest. So if we talked about describing a set and comparing it to another set, you might end up with something that's called the empty set, and I think you might have heard this number in geometry, but to describe the empty set, it basically just looks like this. Let's write down the word empty set. It is the set of numbers, or the set that is empty. So they just take basically a big circle, not a zero, a circle, and a line through it, and then they close the set. So that's the empty set. Pretty much, yeah, but they throw this circle with a line through it in there. Okay, so to describe the empty set, we would get rid of this set numbers, because these things, or this symbol right here, is the empty set. We don't have to put it in a set notation. Okay, so instead of writing set, nothing, set as an empty set, we'll just write big circle with a line through it. So that's your empty set. Okay, so be careful. I know the big mistake is going to be what I showed you at the beginning, is the set with it inside. So empty set is just the big circle with a line through it. Okay, now there's another symbol here. It basically looks like a backwards 3. Looks like that. And I've used it, and I've said it out loud, but again, I don't know if you know what it means completely. This is element. So I'm going to use this in a mathematical sentence. So I would say 3 is an element. So I'm just using, I do a C with a line. That's how I write element. Is an element of the integers. So if you don't know that definition here, go ahead and write down Z like that. That is integer. Okay. So 3 is an element of the integers. As element, I just write a C with a line in it. That's how my professor did it, so they got me all messed up. If you write down the backwards 3, that's the actual Greek, I guess, symbol for it. Now to describe the not an element of, it's just the element symbol with a line through it. So not an element of. Bless you. So this was an example of how to use element. So here's an example of how to use not an element. -2 is not an element of the natural numbers. -2 is not an element of the natural numbers. So really all they are is bold facing a capital letter. But they do that with 2 separate lines, so it doesn't look like it just went over them again. And that was the big part of review 1 that we needed to go over. When everybody picks up their pencil, I'll go on to the next piece. Actually, while you guys are doing that, I'll remind you, the rational numbers are decimals, percents, fractions, right? Irrational numbers are something that we do not know how they end. So rational numbers make sense, we know how they end. Irrational numbers don't make sense, we don't know how they end. Real numbers are all numbers except for anything that includes the I. I is the square root of a -1. That's not a real number. Okay, it's imaginary. So when I talk about integers, that is all of the negative whole numbers, so the whole numbers and their opposites. That includes 0. Whole numbers are 0, 1, 2, 3 continued, and natural numbers 1, 2, 3 continued. Now we should all know how to do that. The next part of the review talks about how to plot numbers on number lines, so I think we're good there. We're not going to go over that too much. I know that we all know how to do absolute values, but I want to give you the definition of it so that you specifically know what it is dealing with. I always talk about absolute value being distance, so we're going to basically talk about distance here. Absolute value, maybe I should write down the whole word. Absolute value is a number's distance from 0. So we always talk about distance in the positive form. You might spell the word 0, and I'm not sure if you will get confused, but we always talk about absolute value in the positive form. So it isn't the opposite. You don't take opposite of what's inside of the absolute value. You take its distance from 0. Because I will never say that I went outside and ran -1 miles or -15 miles. Okay? It doesn't make sense. Okay. Next one. They start talking about adding and subtracting real numbers. Basically, that's fractions. We know how to do that really well, especially on a calculator. We just know how to use the fraction button. Okay? And then they go over PEMDAS. That's, parentheses, exponents, multiplication, division, addition, subtraction. We all know how to do that, I believe. Okay? Goes back on to the commutative property of multiplication, the commutative property of addition. Those are the ones where they just move back and forth. Then it talks about the associative property. The associative property deals with things in parentheses, and I think you guys are pretty good with that as well. Those are both addition and multiplication. They do not work with subtraction. Alright, so talk about inverses a little bit. So the inverse operation for the positive numbers, when we're talking about the inverse operation of a, say 3. The additive inverse of 3 is what? We're going to think additive inverse is what? How do I get 0 from this? I subtract 3. So the additive inverse is -3, just like you guys did with matrices. So what is the additive inverse of -2? Positive 2, right? We get the identity. Inverses produce identities, so write that down. Inverses produce identities. So that being said, if I said, what is the multiplicative inverse of 3, you should tell me 1/3, because I get 1 when I multiply them, and 1 is the multiplicative inverse. So if I said, what is the multiplicative inverse of 2/3, you would tell me what? 3/2, right? Just the reciprocal. And again, you get 1. Okay, that's just a quick example. And that whole review section basically is a bunch of addition and subtraction, multiplication problems. So we don't need to do too much with that. And then they go into inequalities of one variable and regular equations with one variable. And then we get into the stuff that we actually need to start going over a little bit. Alright, so starting on this page, we're going to talk about interval notation. So this is where the main new stuff. This is new to you. So interval notation. You can write that as your title, start a new page, whatever you want. Interval notation. I've showed you this one time, and I said you're going to need this in college. That's why I'm showing you now. And now we're actually using it. So interval notation will look like parentheses and brackets. So the graph of something, we'll give you a general graph here. They use the numbers A and B. So if I have an open circle, is that inclusive or exclusive? Exclusive, okay, so we're going to use those terms again. They say everything in between these two is the answer, so they labeled them A and B. If it's exclusive, we're going to use parentheses, okay? So from A all the way to B, and that's how they annotate it. So this is interval notation. So in a little box right here, make this little note. Exclusive is the ones that go with less than and greater than, and open circles Okay, we will use parentheses. We'll use parentheses with things that are exclusive. For things that are inclusive, or in other words, less than or equal to, greater than or equal to things, where we used closed circles or dots, we will use brackets. Now, if you need a little reminder, draw a little set of parentheses there and a little set of brackets. Okay. So in this same context, I'm going to draw a in general number line here. I'm going to put a closed dot and a closed dot, and then draw them in between. Again, I'm going to use A and B. So here I would use bracket A all the way to B. I'm just describing it from left to right, how I read it on the number line. Okay? So how I read it on the number line, left to right, is what I'm describing here. They get a little more complex as we go. So I'm going to start showing you stuff on this graph in the book. But let me do one more example before I do that. I'm going to do one with an actual number on it. I'm going to use an exclusive dot at -2. I'm going to put an inclusive dot up here at +5. And I'm going to go from -2 all the way to +5. I'm just going to darken in that line in between them. So if I'm going to describe this, because this is exclusive, I have a parenthesis. Then I put the number that it starts at, -2, comma, and I'm going all the way to +5. And because this is inclusive, I put a bracket. So it's really not difficult, it's just a matter of notation. Okay, so interval notation looks like that. As soon as you stop writing on this part, I'll put the chart up there and you can look at it. Everybody still working on this?
Right here.
Alright, so this chart right here, and I'm going to zoom in on it a little bit, is basically the first 3 examples is pretty much what I gave you. Notice the open circles always go with parentheses. So as I look down this, I'm going to put a ruler over top of it. Right here, I should start thinking, okay? There's an open circle, so that's a parenthesis. Closed dot, that is a bracket. Open circle, parenthesis, closed dot, bracket. Open circle, parenthesis. Now, see where the arrows go? If it's just an arrow pointing in a particular direction, I know when we were little kids, you always said, well, that's mine times infinity or whatever. You always said times infinity, right? Or is that just me? Okay, just making sure. All right, so you always said times infinity. Well, actually, infinity is not a number. It's more of a direction. Okay, so if I said I'm going left infinity, that's toward negative infinity, and that's why they describe it as negative infinity. If I say I'm going right infinity, that's a direction. I'm going right towards infinity. Infinity is not a number. We don't go million, billion, trillion, infinity. It's more of a direction. Okay, to infinity and beyond. Okay. So when I start to describe these next sets, and you want to write these down, okay? When I start describing these next set, if I start at A and go to the right forever, okay, that would be the same as saying A is greater than whatever this number is. Okay, so if this was 2, let's say A is greater than 2. But instead of saying A is greater than 2, I would say we start at 2, so that's a parenthesis, but because it's exclusive, and I go toward infinity. Okay, same thing on this one, it's again exclusive, so I'm going from infinity, negative infinity, to, and I stop at B. I read from left to right on my number lines, from left to right. So if I'm starting at negative infinity and I'm stopping at B, I'm going to write it. If I start at A and stop at somewhere in infinity, I write infinity. Again, starting at infinity and stopping at B. Okay, if you want to copy this down, I'll give it to you later, but for right now we need to move on to the next step because we got to write set builder notation.
On the very bottom block, whatever, where it's a bracket A, infinity and parentheses.
Yep. Because that's inclusive, we have to have a bracket there. Anytime you use infinity, you might want to write this down too. Anytime you use infinity, you will always use a parenthesis next to it. Okay, notice this is a negative infinity, parenthesis, infinity, parenthesis, negative infinity, parenthesis.
Can you just do right parentheses, put it infinity sign?
No, you wouldn't want to put parentheses around the infinity sign because then you have two sets of interval notation within each other. Okay, I got to start on this set builder notation. Y'all guys can look at this after a little bit. Set builder notation is basically how we're going to describe the exact same thing. Okay, so I'm going to start on this example right here, where it says we go from A to B. We're going to describe it as a set. So this is set builder. And again, that's a different type of notation, but it's a notation regardless. So set builder notation looks like this. I say the set, and of things, I'm describing them as X. I just give them a variable, okay? I'm saying all things within that set. That's what X is. All things within that set are described where X is, and now I got to say, so X is, if I look back at my A, X is something that lies between A and B. So I need to figure out how to write that using an inequality. So X is less than or equal to A, but greater than greater than or equal to A, but less than or equal to B. And I need to write that down. So it is greater than or equal to A, but less than or equal to B. And then I close my set. Okay, anytime, I repeat, anytime you see one with it shaded in between two things, you will see it in this notation. Okay? This is an AND problem. Yeah.
What is that line between X and A?
This is me saying what is in between. This is a description such that.
They're differently designed. They look like X more. Yeah.
Make your line longer. That's really the only thing I can do for you. I can make it longer.
Does it make sense if I put like one separate maybe? Some circles it?
I don't really know what you're saying.
Like, draw a line and put a dot at the top and a dot at the bottom.
Like this?
No, at the end to the line.
Oh, like a line segment? You made a line segment? Sure, if it makes you feel better, go for it. You'll be able to tell the difference in your book. I promise you that much. Okay. On this one, okay, remembering again that this is exclusive, I'm going to describe this as the set of numbers. This is all numbers that satisfy this shaded area. I'll put her little dots. Okay, then X is going to be in the middle. So I already know that I'm going to have to do this. Because it is shaded in between, I already know that I have to do this. So X is greater than or equal to negative 2. Oh, it's not an or equal to, is it? It is just a greater than on the negative 2. So here, it's just a greater than negative 2. So X is greater than negative 2, but less than or equal to 5. And then I would close that set. These are the more complicated ones. That's why I show them to you. And they do get even more complicated than this, but that's later on in the book. We don't have to worry about that at this very moment. Okay, I'm going to zoom out, and we're going to do one quick set builder on one that goes towards infinity. And I'll even use a real number for you. So here, if we started at negative 5, and it was inclusive, and we are going in the direction of positive infinity, I use an arrow there just because it looks better to me if you don't want to. Very, very, very darkly shaded line. Okay. In interval notation, I would write this as negative 5 going to infinity. And because this is an infinity symbol, I already know I have just a parenthesis. Because this is a closed-in dot, I have to use a bracket. Okay. In my set builder notation, I have to establish my set. Okay, establish your set, and then start describing it as a variable of some sort. So X, so that I know it starts at negative 5 and goes towards infinity. So I know my number must be greater than or equal to negative 5. Okay, It's going to the right. I know it is greater than or equal to negative 5 because it is inclusive. Any questions before I move on?
Negative or 5?
Sorry, negative. Thank you. It is indeed a negative. So, any questions before I move on? I just want to remind you that inequalities have two different ways of seeing solutions, okay? If you get something on an inequality that is true, so for example, if I said x plus 7 is greater than 5, and I solve this all the way out, and I say plug in this set of numbers to solve for it, I say plug in 2 and negative 2 to find out if they are solutions to this set. I will go in here, I'll plug in negative 2, so negative 2 plus 7 is greater than 5. And then I solve that. Negative 2 plus 7 is 5. Is 5 greater than 5? No, so it is not a solution. And if I'm solving an inequality where I have variables on both sides and I get this answer, there are no solutions. Okay? Just like we've been doing, it's no solutions. Plug in 2, I get 2 plus 7 is greater than 5. If that's true, that's 9 is greater than 5. That's a solution, so that is true, and it works. Okay, any questions there? Okay. Remember, if you get a compound inequality, what you do to one side, you must do to the others. Okay? Remember, it's always three sides. And the last example that I have for you guys, it's the longer problem that I gave you. So please, 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 please pay attention on this one. It's actually example 12. There are lots of examples in this book. Example 12 is over taxable income. So there's a lot to read here and a lot to write down. Write down the important things as I read this to you. In 2008, a single person in the 25% tax bracket, that's important, 25% tax bracket, requires to pay a tax of 0.25x minus $3,656.25, where x is the amount of taxable income. So I'm going to define x as taxable income. Okay, so far, these are all the important things that I know. For this tax bracket, the tax due is more than $4,481.25, but not more than $16,056.25. So it was more than this, but not more than this. Determine the range of taxable income for this bracket. Okay? So it has to be our tax must be more than this, but less than that. Okay? So I'm going to read it the way that it says it in the book so that you can see my translation. For this taxable bracket, the tax due was more than, so T is greater than, the tax is greater than that $4,481.25. But not more, so if it's not more than, that would be less than. So tax is less than $16,056.25. Determine the range of taxable income. So since taxes, it told us that the equation for taxes was this right here, I'm just going to plug it in and solve each side. So I'm going to write down my equation for taxes, 0.25x minus $3,652.25. And then I'm going to write in my symbols. So, let me reread this, that way we can correct something. It says not more than $16,000. So can it be $16,000? It says not more than. So it can be $16,000, but it can't be more than it. So we're right on the border there. The other side says for this tax bracket, the tax due was more than. So it has to be more than. Okay, and then I just write in those amounts, $16,056.25 on the right, and then $4,481.25 on the left. Okay, and all I have to do is solve this now. So somebody help me with the calculations because the book isn't a great helper here. We're going to get rid of this 3,652.25 by adding it to all sides. So I'm going to add it to the middle, and that's going to cancel out. I'm going to add it to this side, and it's going to cancel out. Hopefully I do these right, and you're just checking me. I got $19,708.50 on the right. Somebody help me if you get something different. Or if you can just confirm it, that's fine too. Then over here on the left, good, that's what I got. Now on the left, I got to do that one as well. 3, 13, 11, I get $8,133.50. Okay, so now I have two, I should have wrote that bigger. I have two numbers on right and left, and I have 0.25 with my x. How am I going to get rid of 0.25? Divided on both sides, which is the same as multiplying by 4. Somebody wants to get those for me because I can't do that one in my head.
The one on the right is 78,000. I got 78,000. I got 34.
Is it 34?
Mm-hmm.
Okay. I hope you're right.
Yeah. And then the other one, 32,536.
Okay. Say that again. 32,000. What?
534.
Exactly. Okay. So I have
34.
44. 34. Okay. So x then, if I copy my symbols down the whole way, these are kind of crazy numbers, not necessarily large, but they are kind of crazy to write down. So you have to be very careful when you're getting them out of your calculator. Okay. Use that app for math just in case you accidentally put something in wrong. This is our answer. This is our taxable area. So we're going from $32,534 to $78,834. If I was going to write this as interval notation just to get practice in, over here I'm looking at, let's write it as set builder real quick. So we start our set. Our variable of interest here is x. Okay, so we're talking about x. So x is the numbers that range, and then we just rewrite what is inside of our, as our solution. Basically, 32,534, and it must be less than or equal to 78,834. So if you wanted to just go back up and write this and then put it in sets, that would be fine. Okay. Whatever you want to do is fine by me, as long as you get it down. Now let's put it in interval notation. So since this is a less than, this is a greater than, but it's exclusive, I'm going to have an open circle, right? Over here, since this one's inclusive, I'm going to have a closed circle or a dot. I'm going to draw my number line that goes through it. I'm going to answer the question accordingly. So x must be greater than 32,000. This is 32,534. X must be greater than that, so it's going to the right. But it must be less than this 78,834. So it's going to the left. So I graph this to help me write it in interval notation, so I know which way I have to write it. So I start out in a parenthesis. I write down my number, 32,534. And I put a comma in between it, and I end up at 78,834 with a bracket. Okay? And that's really it.